Alright, let's talk about Fabric Failover. Fabric Failover is a very unique capability in UCS, and it provides fabric level high availability to an adapter used by a OS or a hypervisor or a VM. And why it's unique? It's unique because, remember, we're leveraging the capability that UCS has in virtualizing every component of the infrastructure. Virtual adapters, virtual cables, and virtual switch ports. And because these elements are virtual, they can be quickly moved somewhere else in the event of a failure, and that's exactly what we're going to do with Fabric Failover. So here we have a virtual adapter that has been provisioned on this server and is shown to an OS or hypervisor as an adapter. And that virtual adapter, of course, has a virtual cable. In this case, we've chosen Fabric A for that primary virtual cable to flow up to its virtual Ethernet port on Fabric A, 6100A. And that virtual Ethernet port is pinned to an uplink. In this case here, the red uplink. Now, should anything fail along this path, including the uplink port, the Fabric Interconnect switch 6100A, the ports, the fabric extender, the physical port on the physical adapter. If anything should fail along that path, we will engage a Fabric Failover event and quickly move that virtual cable over to Fabric B and to an identical virtual Ethernet port on Fabric B and pin it up a new uplink on Fabric B. All of this happens very quickly in under a second. And meanwhile, no failure event has been shown to the OS at all. The OS does not see the NIC card go down, does not see any disruption. All of this complete fabric level redundancy was provided by the system level capabilities of quickly moving pieces of the virtual infrastructure from one fabric to the other. So you can provide high availability for an OS, for a hypervisor, with a single adapter. You do not have to fuss around with multiple adapters, with multiple cables going to multiple switches, and fussing around with NIC teaming or bonding drivers. All of that complexity can be absorbed into Cisco UCS's capabilities of switch port, cable, and adapter virtualization. So let's take a quick look at how to use Fabric Failover and what are some of the use cases that customers are using. And one of the primary use cases at the very onset was to use Fabric Failover for bare metal OSs on a physical blade, where you were not using any kind of virtualization or VMware or Hyper-V or anything like that. This was Windows or Linux loaded right on the bare metal. And typically, as you would do with these type of installations, is to provide the high availability for that OS, you would have multiple adapters with multiple cables going to multiple switches, and you configure NIC teaming or bonding and that, and you'd have to make sure that you've got your primary adapters and your backup adapters all configured correctly. Well, all of that goes away now with Fabric Failover. We can provision a single VNIC, single adapter to this server. So you've got a Windows or Linux machine with a single 10 gig adapter, and the high availability is absorbed into UCS with Fabric Failover. So you've got a MAC address, of course, on that adapter for that Windows or Linux machine, MAC address A. MAC address A is an implicit MAC on the Fabric Interconnect, means that it was authoritatively known. This was defined in the service profile that you use to configure this service. It's not a MAC address that was really learned by the Fabric Interconnect. It was just known when you instantiated the service profile. And when you enable Fabric Failover for the server, MAC address A will be replicated across that cluster link, so 6100B knows that MAC address A is out there and know that it's waiting for a failover and is ready to pin MAC A up on a new uplink should there be any Fabric Failover event. And if there was, MAC A would now be active on 6100B. It would be pinned on a new uplink. 6100B would send a gratuitous ARP up the new uplink to alert the upstream network of the new location of MAC A, and all of that would happen very quickly, under a second. Meanwhile, the NIC stays up, no disruption to Windows or Linux, and basically you don't have any of the complexity of NIC bonding, NIC teaming drivers, and you've got high availability. So you really have everything to gain and nothing to lose by implementing Fabric Failover with a bare metal OS, and that's why I'm really calling this a slam dunk scenario for Fabric Failover. Alright, now here's where things get interesting. Let's talk about Fabric Failover with hypervisor installations. And in this case, we're going to talk about Hyper-V. Now, in version 1.4 of UCS Manager, there was a new capability introduced to provide Fabric Failover for learned MAC addresses. So prior to version 1.4, it was always possible for the implicit MAC addresses, that was for the bare metal OS installations, but it was never a supported implementation for the learned MAC addresses that you might have learned from a hypervisor switch running on a server running Hyper-V or VMware, for example. But with version 1.4 of UCS Manager, now these learned MAC addresses are supported with Fabric Failover. So here's another slam dunk scenario for Fabric Failover, and that is with Hyper-V. See, Hyper-V really has only supported using one NIC for virtual machine traffic. Hyper-V has always been missing high availability and redundancy in its software switch, and you can reference Microsoft KV 968703 to read more about that. So Fabric Failover really comes to the rescue for Hyper-V installations in delivering that high availability that's always been missing. So now we can take the VNIC that we'll define in the service profile for the VM traffic for Hyper-V, and we can enable that with Fabric Failover. So all of the VMs here, we've got a couple of VMs, Mac A and Mac V, and those are going to be learned MAC addresses. So the Fabric Interconnect A over here is going to learn Macs A and B, and with version 1.4 running in this system here, those are learned Macs. Those will be replicated over to 6100B with Fabric Failover enabled. So we have coverage there. And 6100B will wait for a failure, and we'll have uplinks ready to go to take over in that case. And if there was any failover, it would become primary for all of these MAC addresses, and it would pin them all on a new uplink and send a gratuitous ARP for all of the Macs here that need to be resumed, such as Mac A, B, and C. So 3 gratuitous ARP messages would be sent up, and all of the traffic from the upstream network would arrive now at 6100B, and the failover is complete. So with Hyper-V, Fabric Failover really is a slam dunk. There's everything to gain, and there's nothing to lose. You're bringing a lot of the high availability that Hyper-V has been missing up to this point. So UCS comes to the rescue with Fabric Failover.